Well, hello again and welcome to the VK6CS amateur radio channel. I'll show you something that I think is reasonably interesting. Now, remember before I was talking about these this column of resistors here. They're the dropping resistors for the plate voltage meter, panel meter. And I calculated what that value should be. What I did was I got a dozen 1 meg resistors, put them in series parallel, and I thought the tolerance of the resistor values may give me something close to the value I was interested in, and it did. However, when I connected it to the meter, I didn't get the it didn't read accurately enough. So what I've done, I didn't film it, but what I did earlier was put a pot. You know, in the last video I said I was going to put a pot there. I put a little pot there and adjusted the pot so that the meter showed an accurate voltage, and then I measured the value of the pot. Now, these resistors here aren't quite the same value as the pot, but I reckon they're going to be close enough. But I'll just show you what the resistance of the string is. Now, these are all 1 watt resistors. There's a lot of them. I'll probably leave it like that. I don't think I'll make it any smaller physically, you know, by changing resistor values and making it smaller, because I want the thing to be robust. You know, I want to build the thing, bolt it all together, and just forget about it. Really, forget about what's inside it. So by having a lot more resistors to dissipate any power or anything, it's just going to make it that much more robust. There's only a milliamp running through this string of resistors, but the resistance I end up with if you can see that, 3.61 megohms. 3.6 well, as I say on every video, this is amateur radio. 3.57 megohms. Okay, now actually I'll just write that down. 3.57 megohms. I'll show you the calculation in a second. So that's 3.57. You can't see that, but don't worry about it. Okay. So what I'll do now is I'll just see how well that resistor value works. As I say, it's not quite the same. I haven't actually tried this. It's not quite the same as with the pot, but it's reasonably close, and it's a very high value string of resistors. So, you know, resistance. I mean, you know, they're not made of plutonium or anything like that. You know, so don't break into my house and steal them. And then sidle up to somebody and say, "Here, John, you want to buy some resistors?" Yeah, why is it? We always assume people with beanies talk like that. Okay. Right, so I'm just going to tack this wire on here. Doesn't have to be a work of art, because the actual this wire will be cut to length and then soldered on the board properly. When it's in the amplifier, when both the meter and the board are in the amplifier. But this will, let's just see how accurate. So I put that over to there, reconnect my high voltage probe, and squirt some juice into the high voltage power supply. What I'll do first is, let's just get that other meter in shot. as well. So what you really want is those 2 meters there. There we go, which is the panel meter. Panel meter and the digital meter. Okay. All right. So let's set the voltage to, I don't know, 2000 volts. Get on there. Can't see the digital meter, that's the trouble. 3, 4, 5. There we go. 1000 volts. 1300, 400, 500. Looks reasonably good so far. 800, 9. Come on, yeah. Okay, this is going to be pretty close, I think. 2000 volts. Okay, so now put the probe on. That's showing 200, or it's showing 2, but remember it's times 1000 with this high voltage probe. That's 2000 volts, and the needle's showing pretty much 2000 volts. So I think that's looking pretty good. So now let's wind it up to 2800 volts. Now on this meter here you've got the so that's 2000, 220, 240, 260, 280, 3000. So let's just put that on there. Okay, and wind it up to 2800. (2800 volts). 2.8, remember, is 2800. And that meter, the needle is now on the in the correct place. That's showing 2800 volts. It's actually showing just a hair under. Actually, no, it's the angle. I'd say that's showing 2800 volts. And if I wind it up full, there we go. That's maximum smoke, almost literally. And that's just a whisker under 3000 volts. And what have we got here? 3000 volts. There we go. Oh, 2990 volts. 2.99, 2990 volts. So that just being a whisker under the 30 there. Remember the 30s, 3000 volts. That's pretty much spot on. So I'm happy with that. I'm now happy with that resistor string. So that will stay in there. I won't muck around with that. That's just a nice robust string of resistors that will act as the dropping resistor for my 0 to 30 volt meter. So this is now reading 0 to 3000 volts, and it's indicating just a whisker under 3000 volts, and we've got 2990 volts indicated on the meter. So yeah, very happy with that. So that's yeah, well, I haven't got a clip on there, but yeah, so that I would say is plenty good enough. That looks pretty good to me. Now, just for fun, I'll wind that off. I was thinking about putting my tongue on there just to see if it feels like you know, just under 3000 volt, but I thought I'll leave that to for maybe another episode. Right, now. Remember what I said about that resistor value? How can we do this? Can we do this? I move this tripod around like that. And then I get my board. Now, that's B-O-A-R-D. I do apologise if you're getting B-O-R-E-D. But you can always, this is YouTube after all, you can always exercise your right to hit stop and leave a nasty comment. Okay, now let's see if we can get that a little more centralised. It's bloody awkward doing this. Is it worth it, I wonder? Let's have a look. Actually see that, I can't see that 3 meg ohm because I don't know why, but the display on this bloody camera goes dark after about 10 seconds and I've got no idea why. Okay, let's just get that out. Good old autofocus. Alright, well I'll try and keep anything I do to the right of that 3.57 meg written in the top left hand corner. Now remember, that was the value of my drop-in resistor. Okay, now I got that meter from Ultronics. Happen to have a handy Ultronics catalogue here. Of course, because of the tripod I can't get the bit that I want to show you in front of the camera. Isn't that marvellous? Okay, so this is the meter I've got. 0 to 30 volts. It's the Q0525A and it tells me that the coil resistance or the internal resistance of this thing is 30,000 ohms. I measured it. It's actually 30,200 ohms, the internal resistance of that meter. Okay. Now, Ultronics give me a formula here. A voltage multiplier formula, so that I can use that 30 volt meter. Is that in focus? Apologise if it's not. And it gives me a formula for how to calculate the value Rx of that dropping resistor. Now I'll just show you what happens when you apply that formula. Okay. So remember, we're going to calculate Rx. So Rx is, if that's plus 3,000 volts, that's our meter. This is Rx. Okay. Now Rx, according to Ultronics, equals V over A minus Rm. Now I do hope this focus, I can't see the image when I'm doing this, so I do apologise if this is doing anything weird, or weirder than normal anyway. Okay, so Rx, where Rx, the resistor, equals Rx rather is the value we need. V equals full scale deflection voltage required. A equals FSD current meter. And Rm equals meter resistance. Okay. All right. Now I am going to use a calculator because although I'm not that bad at math, I'll always take the easy way out like everybody else, if possible. Okay. So what do we want? We want V, voltage required, so that's 3,000 volts. We need to put that over A, which is the full scale deflection current of the meter. And to get that, say, okay, I will equal V over R, so that's 30 divided by 30,200 equals, I don't know if you can see that, 0.00099. Okay, well that's 1 milliamp really, that's 0.001. So 0.001, and that will be 3 million. Showing the calculator. So 3,000 divided by 0.001 equals 1, 2, 3, 4, 5, 6. So that equals 3 mega ohms. Okay, that's 3 mega ohms. Now we then have to subtract the internal resistance of the meter, which is 30,000. So we have 3, 1, 2, 3, 4, 5, 6, 3 megs minus 30200. 30,200 equals 2.969, we'll call it 2.97 megs. So minus the 30.2k ohms equals 2.97 mega ohms. Now I hope you can see that. Can you see that? Yeah, okay. Now you would think, okay, I'll put in my 2.97 mega ohm resistor. So I make that 2.97 mega ohms. That's then going to read 0 to 3,000 volts. But that is not what happened. Remember? I had to, so I did that, and then I had to fudge around with a pot to find the value to put there that would actually give me a full scale deflection of 0 to 3,000 volts. And it turned out to be, see that there? It turned out to be, yeah, 3.57 mega ohms. So there we go. So as to why, I've got no idea. I've measured the internal resistance of the meter, measured the value of the resistors. So why that formula falls short, I really don't know. Maybe someone could let me know. But anyway, the important thing is that I now have a value in there that shows me an accurate HT voltage. So that part of the power supply can have a line drawn under it. I'll move on to the next bit, which will be the soft start and the bias, the cathode bias board. So anyway, I hope you found that interesting or informative, or both. As always, thank you very much for watching. There we go, a bit more professional camera work there. Thanks for watching, have fun, and I'll catch you next time.